So is that good? Is that bad? I don't know. Depends on the use case. Depends on what you think about PyTorch as far as like where you can take the code. Leo says, yeah, Leo. I mean, I think it's clear, right? Like if you look at these numbers, like the mean of the loss is probably the highest we've seen. Like 0.73 for a loss? That's terrible. Even 0.33 is, not so hot. Right? The confusion matrix looks okay, right? Class 1 and class 3 are excellent. Yassine says, if I remember correctly, the code that generated the data used 15 informative features. Just a dumb thought, but wouldn't it make sense to use a layer with 15 neurons before the output layer? My rationale is if we already know how many variables are significant, let's consider every neuron as a variable and let the model learn them. So Yassine, it's not the output layer, it's the input layer that matters at that point. Right? See, I'm not on board with where you said about the output layer because your features and your outputs are, there's no relationship there. Your inputs are what they are and your outputs are what they are. They're completely independent of each other. Right? I mean, that's why you have the layers in between, because the layers and those calculations is what helps you make those relationships, right? Those relationships that you can't see. But there is no correlation between your inputs and the number of outputs. In many cases, it's much more common for the outputs, but in many cases, they'll be dictated to you, right? Like the number of categories your business needs is what the business needs. You don't decide that, and the features don't decide that. So no, Yassine, I'm not on board with that because they're completely independent of each other. On the input side, it matters, right? 20 features needs 20 nodes to start off. But otherwise, no, doesn't matter. They're completely independent. But I'm still confused in real world scenarios. How would I select a model? What balance of losses and accuracy is what I'm looking for? Yeah, Rahul, depends. It all depends. It depends on the use case. And again, some of those, they might be dictated to you, right? So for example, going back to this chart here with the classes, let's talk about this chart. Can I make this a little bigger? I can, cool. Let's talk about this chart. So I know it says the class 0, 1, 2, 3, 4, but these in most scenarios, these would be like product classes or some sort of end result to a process, to a sales process, to a production process, whatever, right? So the business might dictate to you what they need out of this, right? So let's take class 3, right? Class 3 is properly classifying 393 of the 400 items that are in that data set, okay? And you know that the accuracy here is 91, the loss is a little shaky, right? We've already agreed on that, right? But the business might come to you and say, that's fantastic, we want this model. And they're going to tell you that they want the model because these, any number that's not in the 393 is basically a mistake, right? And the business might tell you, well, every time you properly tell us this, we make $500. And every time we make a mistake, we lose $3,000, right? So we're ecstatic that you're only making 4 mistakes. Like, that's great. And then you're going to say, but wait a minute, this model really stinks for class 2. And they're going to say, that's okay, because these mistakes only cost us $10. Right? So we're okay with a model that's optimized for class 3, because that's when you're saving us the most money and you're making us the most money. Right? So it's totally okay, for you to make those adjustments. It will be like literally dictated to you to say, I don't care what the model looks like. I don't care what you use, Keras, PyTorch, a room full of monkeys. Just don't make mistakes in class 3, because those are really expensive mistakes. Like, I've been in situations where that happens, right? Like, you can sit there and you can break it out and actually assign values to your mistakes. And then sometimes the outcomes themselves have probabilities. So you got to do, these expected value formulas, blah, blah, blah. But you can sit there with the business and they will tell you that I don't care about the accuracy. I just care that you're not making a mistake here, because that's where our money is, right? So Rahul, you're asking a great question, but it's not always an academic exercise. It's not always a black or white answer. Like, it will be dictated to you, and there will be some hard numbers behind it. Like, some very logical numbers behind it, right? So yeah, so that's really my best answer to you. So Leo says, yes, but achieving a higher accuracy without overfitting is a heck of a challenge. Yeah, but it might not matter in that scenario, right? It may or may not matter in that scenario that I'm telling you about. Again, they can assign dollar values to all of these. So they might be okay with an overfit model that optimizes for class 3. Because again, those mistakes are very expensive. And they could tell you, hey, right now we're making 50 mistakes a day that cost us $3,000. If you're telling me you can only make 4 mistakes that cost us $3,000, we love you, right? They're going to love you for that. And again, they don't even care if it's Keras, PyTorch, or a room full of monkeys. They just don't want mistakes in class 3. And they're okay with mistakes in class 2 because those are the cheap mistakes. So it just depends. It just depends, guys. That's the real world stuff that, even the academics don't have a good grip on, right? Because in academia, they want perfection, right? Don't overfit that model. Give me a model that meets X accuracy. Well, that's not always the real world. That's the academia world, but that's not the real world, right? And again, I'm telling you this because I've been in those meetings where we will sit there and we will say, okay, well, here's the cheap mistakes, here's the expensive mistakes, and that's where we want you, Dennis, you, the data science team, to go in that direction. And then Leo, as far as like how do you actually achieve that? You know what? Sometimes just Monte Carlo it, right? You can Monte Carlo this. You'll have to set up a process. You'll have to monitor your outputs. You monitor your accuracies, monitor your confusion matrix specifically for the class that you're interested in, and just let the processor fly, right? And then eventually you'll come across a model that meets those needs of saying, this is your best outcome for the business, not for academia, not for perfection, not because it's the best accuracy or F1 score or whatever, but because it's what the business needs.